started. Hello all. I'm Mallik Bulusu from Microsoft, and I'm going to co-present with Sami from Intel. Today's topic is more about a specific operationalization aspect of in the cloud, how we maintain the fleet hygiene, and some of the ideas that we have, we would like to bring it to the forum. So the topic has two parts. Although the slide header says it's challenges, one is an easy part and the other one is a challenging part. I'm taking the easy part and leaving the hard part for Sami to talk about. One of the things, if you look at the evolution of cloud and the trends that have been, the guiding force behind the way the kind of server designs are going into cloud, it's all basically the workloads. We are going to an era where machine learning, deep learning, artificial intelligence, and large in-memory data sets, these are all guiding how the data center hardware is getting defined. So there is a concerted effort across the ecosystem to push for standardization. An example of a standardization is, for instance, the Microsoft Olympus rack definition and Microsoft Olympus blade definition, right? So these are standard building blocks upon which we can create solutions. That is one premise. But one of the things is that standardization is something that you cannot arrive at in a minute or in an instance. It evolves. We learn from our pitfalls and we refine it, and eventually we land on standardization. The other thing is, we have, apart from standardization, there's also specialization. When I say specialization or customization, I'm alluding to the nature of workloads, the demand for offloads. For example, PCIe offload engines, maybe FPGA or something, or custom silicon, maybe silicon building blocks for security. Then we're also going into an era where memory is like, we're getting into storage class memory. It's hybrid memory, which acts as storage or memory at the same time, and it can be configurable too. So all this, right? Anytime you have custom hardware, there's not a single hardware which doesn't have some programmable firmware that controls it, makes it usable. At the end of the day, whatever solutions we're creating between this standardized hardware and the customized endpoints, there got to be something that is connecting these two. Actually, I owe a lot to, in fact, some of us in the room may agree when I say, we owe a lot to PCI spec. PCI system, bus system, or PCIe, the way it evolved, how it helps kind of create the symphony between something that is totally customized versus something that is getting standardized, right? So at a system level, we have system BIOS or system BMC. They help power the system. But the custom hardware also has the programmable components. They all have to be updated to. Oftentimes, BIOS doesn't have the functionality. In fact, the topic that we were talking about, people want to remove a lot of functionality away from BIOS, put into Linux or put into cards, let them talk about their initialization needs and things like that, right? So programmable firmware that is sitting on the endpoints is something that also has to be managed. So in the cloud, we have to solve these problems. And if I give you a high-end server, every single firmware element can be easily updated. We have bus interfaces through which we can talk to. There's not a single firmware that cannot be updated. So then why are we talking about that problem in front of this forum here? Managing this at scale is a daunting task. Updating firmware as such is not a big deal. But updating the firmware in the fleet in a way that you are doing it in a hands-free manner is where challenges are. And one more challenge is, there are certain workloads, as long as storage is disaggregated, you can do the VM migrations or container migrations. It's very easy to service the node when container count is 0, right? But on the other hand, we are going into very large in-memory data sets. Let's say we're using storage class memory such as NVIDIA-N or something. If the firmware on those modules need to be updated, migrating large volumes of data at scale is going to be a big deal. So we really have to come up with a case-driven approach, right, to come up with some clever solutions. And when I when I approached Sami and Mohan and Intel team and on this problem, on the one hand, we want something standard and customizable, all these things. So we try to ponder about what the problem space is and come up with ideas that we have and bring it to the team here, right? So yeah, I think yeah, we can go to the next slide. So that said, the other aspect is we want to solve it in a way we don't compromise on some of the existing needs. For instance, supply chain integrity. When you have these PCI endpoints, which are coming from various vendors, they have their own, they change hands between vendor A to vendor B to system integrator to data center, right? So we don't want supply chain integrity to be compromised. We want, ease of deployment at scale. Things like updates have to be impactless. When I say impactless, essentially, if VMs and containers cannot be migrated and still have to service the node, we want to do it in a way that the existing workloads need not be torn down, right? They have to be probably preserved somehow in the memory, and things like that. And we want to get to a world, and again, we don't have all the answers, but we want to get to a world where how we, harmonize the challenges that we have, just so any node in the data center can be seamlessly serviced. I think this is the premise on which we want to build on, and I would let Sami to handle the hard part now.
Thank you, Mallik. So actually, if you look at solving this runtime firmware update or runtime configuration change, what you are really looking is your system is running, its VMs are loaded. Now you need to prepare the new configuration to be ready, and you want to deploy it quickly so that it can be up and servicing the VMs back. So if you really look at it, we basically stop or pause the VM, and then you want to activate the new firmware that you already have it, got it ready. Then you want to bring the VMs back. Right, high availability is really important. So in order to solve this problem, you can take multiple approaches. I will kind of start walking through a few that we are thinking of. Again, we would like to see your feedback and how you want to go about it. So today, what we have today, we generally have multiple images in the platform where you're running out of one image. You can download this another image to the flash. On the reboot, what you're really doing is you're switching from the currently running firmware to the new firmware that you're going to have. And again, if you look at the problem further, right, it's two-step process. You need to reboot. And until that reboot happens, you're not using at all. Again, like Mallik said, migrating the workload from one system to another is a big challenge. Then if you don't want to migrate it, you need to have some other mechanism to deal with it. So when we started looking into this problem, there is a multi-phase things that we need to look at it. One is, what are the primitives that we have to activate this new firmware without really resetting the system? Complete reset, we want to avoid it. That means you want to preserve the memory that you already have in your system, but you want to still bring the new firmware in. And that means you need to split your firmware into at least two phases, where you want to have the memory part of the code is not changed, the remaining part can be changed. And if you want to do that, you need to have primitives in the BIOS, or you need to have primitives in the OS to request it, and you need to have this security mechanism that you're able to say that now you have got a new firmware that you're running on this on the existing one, still it's good to go. And again, when we started looking into this problem, you have monolithic firmware today. Even though there are modules today, we can go and update the capsules. You have devices or you have modules there. But even you update the capsules, you cannot activate them. Even if you activate, if in order to activate, you need to go through the reboot process. So I think what we need to really look at it is create a service-based modules rather than just monolithic capsules that has to be run. What I mean by that is, even today, if you look at the setup options, BIOS has hundreds of setup options. Not all of them really requires a reboot. But we designed our firmware such that you have to do a reboot to get those functionalities in. So if you have the setup options that I can invoke at runtime to get the new functionality, you got this new service up and running. And if you extended that further, your new firmware is nothing but a new personality that you are trying to add. That personality service has to be, you need to bring it up and running. But in order to do that, you need to have more primitives about what is my dependency, what is my previous state, what is my next state going to be, and how do I make sure those are not going to break any running systems functionalities there. Again, if you break it, there may be some of the things going to touch the hardware. Some, it's probably providing control plane activities. Or some, you have bug fixes in your runtime code that you need to fix it. So we need to think through all those different things, and we need to bring a service-based modules rather than a fixed code modules there. Again, you need to be modular, service-based modular, and you need to be able to authenticate those things. And you should definitely audit and verify those modules and able to activate at runtime. So further, in order to get a primitives, we need to have a coordination from the operating system side. So you cannot just go and enable this new functionality that you brought it in. Maybe it's already sitting in your firmware. Like I said, setup, you can go and enable some new functionality. You cannot do it randomly. So you need to bring operating system to a state where they are really ready to cooperate. They're not really doing like control plane operations. Or even if you are doing some data plane operations, you can able to control or you can set some known state so that you can change the parameter and bring it back. So again, what we are thinking is, you got this firmware modules available, you updated the modules, is sitting there. Then invoke the preserve VM functionalities and do a warm reset kind of operation, but it is the memory contents are not lost. Then your new functionalities are brought in. And obviously, if your bug fixes are affecting your memory training or memory modules or any of the interlinked things, you need to go through the complete reset. And again, if you look at Windows and Linux, you have the starting primitives are there, but you need to enhance it further to invoke this firmware activation mechanism so that you can able to get this new functionality ready. Again, for the security part, so normally we are measuring the firmware that you have it today, and even some of the configuration you are measuring and you are putting in the root of trust. So now when you get a new firmware in, you want to make sure that those functionality, that services that you're going to bring online, even that is attested and authenticated and ready to use before you invoke any new functionalities there. And in summary, I think what we are really trying to say is that we need to get this runtime firmware functionality, personality change. Things need to be available for the cloud service provider to use it. And also need to have a highly available modular firmware interface. And we need to comprehend not only the firmware part, we need to comprehend OS part, you need to comprehend the security part. We need to go and define this new mechanism of delivering the firmware at runtime, and we should do it as a open partnership. Anything else you want to add?
No, I think.
So I think really like we want to have more interactions. We would like to hear from you what you think and what type of concerns you have.
So I just want to add a couple of things. The runtime, the policies that if you want to tweak from runtime, I think it can also tie back to some of the PRM concepts that Sarathi talked about this morning. Perhaps we can examine the policies that are tweakable in runtime, and somehow have these interfaces, because I think you touched upon very interesting. Again, this is an idea that we probably have to pursue in the OSF realm. Today we have the OSF tree that actually is kind of solidifying. We're going through this notion of FSP that kind of binds the goals, that we have common goals that we have between either the Linux boot or the EFI boot path. I think, with concepts like PRM can also be plugged on top, so policies that could be.
You're ready. I think we really want to get this PRM that doing a service of the things. We need to be able to get a new functionalities firmware to be able to put in the PRM and able to activate that, because it's provided a lot of runtime functionality. If you look at a lot of RAS-related issues, having this runtime mechanism is really going to help on solving a lot of problems over there.
Yeah. So I think, OSF, there's this forum, Ron Munich and Devendra Gav from Microsoft, Ron Munich from, I think, Google, they kind of chair the committee. We encourage you all to take part in this, and let's try to, make this, I think the constellations have to form. It's like the stars are there, and it's a matter of the key pieces that can make the magic are, I think, I see forming. So let's all come together. That's a call to action more than anything.
And to add, it's just not by us, it's all the components.
Yeah.
So when we have more components, we're going to have more problems there.
So,
go ahead.
Yeah, you have a question?
Can you go back a couple slides? I think it was where you had the order where it was going to reset.
Yeah.
So
are you still suggesting that you go through a capsule update mechanism on this reset?
So, like I said, two different things. One is either you have this functionality already sitting there. For example, like if you look at a lot of BIOS setup options, you have those some of the functionality. For example, enabling error threshold. Those kind of things are available. You don't really need to go through a reset, capsule reset or anything. You want to bring this new functionality.
Yeah.
The second part is you put a new firmware in, right? Once you got a new firmware, you need to bring that activated, right? In order to do the activation, you need to tell that new module, if you write it properly, it provides a service, and say this, now you get this new service up and running. In that new service, either you patch the existing functionality or it does the additional functionality to you. It's how do you design your firmware modules over there.
I can add to it a little bit. So today, there are a variety of components, right? Like, just take the system firmware, key core pieces. Let's say there's no PCI cards, no option RAMs, nothing. System boots on its own, whatever, right? So we have BIOS, we have BMC, we have ME, we have microcode. Let's take the example of microcode, right? If you have to do a microcode update for whatever reason, and if you have to update the BIOS and restart the system, obviously there's an impact to the VM, in that your VMs have to be migrated. We don't want to do that, right? So there is a provision today, even for example in Windows, we can do hot patching, right? So think of that, right? The same model can be extended to other critical platforms. Think of a runtime BIOS element that sits in the OS context but is like orchestrating with maybe the PRM primitives or whatever, right? That is one way to look at it. So there are ways by which I think Sam is also mainly alluding to when these updates are attempted, there is still a need for some kind of quiescing. You need to either memory map level or something. Systems have to be in a clean, the node has to be halted or brought to a clean state, update the firmware, initialize it, bring it back to the, and then basically activate the old context again. So this is doable. We know it will work for sure. But again, how we maintain it, it is also serviceable because I can always, even if I don't do a BIOS update, restart the node, as long as the delta patch is maintained in the OS in some secure location, I can always reapply that patch on every single successive boot. So your BIOS configuration or the BIOS features that you are enabling once the OS is booted are not going to be different across boots. So this provision is doable, actually.
So think of this way. Microcode, we have a late binding batch, early binding batch, and a patch that does a reset. Need to go through the reset to get that functionality in. So you can apply similar concept for the BIOS or any other firmware that you have on the system.
But in some of the cases, you're still suggesting doing a form reset, preserving memory.
Correct.
But doesn't this also open you up to additional security attacks of where on that reboot path, something may have changed the way that the system would be booted with the secrets now in memory?
That's, we need to solve the security problem.
Yeah.
I agree. It's not solved.
So again, think of it. There are two parts there, right? See, when we say firmware, there is system and device. If the system firmware problem can be reduced to a device firmware problem, the nature of resets is different. You may not even go back to the boot paths, right? So that is one thing that PRM will help. That's what Sam is actually talking about. Then there are cases where resets are done, then additional security measures have to be taken. And again, even Cerberus is like right now evolving. That's another thing that can be tied to some of these aspects. And again, we have not got all these problems solved, and probably OSF is a place where let's all.
I'm not saying that it was expected to be solved. I just don't want it to be overlooked.
Right.
No. Yeah, I mean, we are very mindful of what we are saying because we know that I think the platform personality hooks that we expose to the end users today are way too many. And we need to also know each variable has a different kind of life cycle and a scope. But we are all using the brute force method, update the NVRAM, restart the system, right? We cannot be agile and also be, carrying a 1,000-pound load on the back, right? We need to figure out where to cut what kind of load and what to carry to which endpoint, right? I think it's a process. I think what Sam is also mainly highlighting is the notion of the modularity is not an EFI driver. It's the specific functionality that has to be serviceable. I don't think architectural primitives are there today, but the plumbing to get there is already forming. It's definitely there, right? We need to all collectively sit together, better architect it, and and then I think that's the OSF. Again, I want to go back to the same point. Let's contemplate on these kind of issues there.
Yes.
Thank you, Sami. Really appreciate it.
Thank you. Any other questions? Good. Thank you.